Conjunction logical operator. The conjunction logical operator is represented with a symbol which looks like an inverted V. This logical operator can also be represented with the symbol ampersand. Sometimes the simple English word and can also be used to represent the conjunction logical operator. First, let's look at a few examples to understand how two different propositions can be combined by using the conjunction logical operator. 10 is divisible by 5 and 5 is an odd number. This statement contains two propositions. 10 is divisible by 5 is the first one, and the second one is 5 is an odd number. These two propositions are combined by the conjunction operator AND. 15 is divisible by 3, but 3 is an even number. This statement also contains two propositions. First one is 15 is divisible by 3, and the second one is 3 is an even number. And these two statements are connected by the word but. Here we need to understand the word but is playing the role of a conjunctive operator. Now let's try to understand the definition of conjunction operator. Let P, Q be two propositions. P conjunction Q is true only when both P and Q are true. Let us understand this with the help of a truth table. P, Q, P conjunction Q. If P is true, Q is true, then P conjunction Q is true. If P is true, Q is false, then P conjunction Q will be false. If P is false, Q is true, then P conjunction Q will be false. If P is false, Q is false, then P conjunction Q will be false. From this table, we can easily observe that P conjunction Q is true only when both P and Q are true. The same table can be represented by using the numbers zeros and ones. If P is 1, Q is 1, then P conjunction Q is 1. If P is 1, Q is 0, then P conjunction Q will be 0. If P is 0, Q is 1, then P conjunction Q will be 0. If P is 0, Q is 0, then P conjunction Q will be 0. From this table also, we can observe that P conjunction Q will be 1 only when both P and Q are 1. From the above table, P conjunction Q can be mathematically defined as P conjunction Q is equal to minimum of P, Q. We can verify this formula with the values given in the above table. 1 conjunction 1 is equal to the minimum value between 1, 1, which is 1. 1 conjunction 0 is equal to the minimum value between 1, 0, which is 0. 0 conjunction 1 is equal to minimum of 0, 1, which is 0. 0 conjunction 0 is equal to minimum of 0, 0, which is 0. That's why we say P conjunction Q is always equal to minimum of P, Q.